So I'm going to, I don't know if I'm going to go over all of it. I'm going to go over the hard parts, and then I'm going to let you guys do the easier parts, okay, on your own. But usually I assign this as like a thing to do over the weekend where I have you watch the video. Today we just have time, and I figured I would do the notes in class. That way you have more time for your study guide, because your study guide's a little long. You still have a practice I want you to do over the weekend for this. But your study guide's over the weekend, which means what's happening Monday? Our Unit 2 test is Monday. Our Unit 2 test is Monday. So, yeah. So you have your study guide and an FRQ practice. This would have been the notes. I'm going to do the notes with you in class today. Save you a little time because we happen to have that time. I'm going to skip sketching the slope field for now just because I don't feel like that's something that we're challenging with too much. But if we have time, I'll go back and do it so to save you guys time. But let's talk about a weird question here, number 2. Describe all the points in the xy plane for which the slopes would be positive. Okay, well, here's my slope up here. Positive. Well, there's 2 ways that this thing could come out to be positive. Actually, I only see one. First of all, we have -3 being multiplied by an x squared, which is being multiplied by a 2y minus 6, right? Now, I want to know, in what circumstances would this come out to be positive? Because that will tell me where that happens on the graph. Well, that is a negative number, right? What is that one? And you guys should be writing it. X squared. What would that be? Negative? Positive. No matter what you plug in, that will always be positive. The only exception would be 0, right? But if you plug in a negative number or a positive number, you're going to get a positive out of that. This is the only one that we don't know. Okay? But I do know that that first one's negative, the second one's positive. I don't know what that is. The question is, what would make all of this positive? Well, if I want this all to come out to be positive, what would this one have to be? It would have to be negative, because a negative times a positive times a negative is the only way to get a positive. So that means that 2y minus 6 must be negative in order for the slopes to be positive. All right. Now, mathematically, how do you show that something is negative? Using inequalities. If it's negative, then it must be what to 0? It must be less than 0. Okay, so they want to know, where would the slopes be positive? Well, since this is negative, this is positive, this would have to be negative in order to get a positive. So we know that 2y minus 6 is negative, so that means 2y minus 6 must be less than 0. And can we just solve for y now? I think we can. So if y is less than 3, then that's going to make this negative, which is going to make this negative, which will give me the positive outcome I need. So describe all the points in the xy plane for which the slopes are positive. All points where y is less than 3 is the answer. Okay, so I've seen that question a couple times on FRQs. It's not a real popular one, but it's popular enough to where I've seen it a few times. But the point there is you have to kind of analyze your differential equation and ask, what would that piece have to be in order to get what they want? Then you set up your inequality and you solve it. If you're right, Jesse, you'll probably have a better time saying it.
I did it. I have it.
All right. head's like bobbing all over the place. All right, so there's that. All right, so that's one type of question I want you guys to be prepared and ready for. Another type of question, can I move on or is somebody still writing? Okay, is this guy. Number 3. Maybe it is. Let's see. Find the particular solution. All right, this is old news. We've done it. That doesn't mean it's easy, but it is something we've done before. So we have negative 3x squared, 2y minus 6 is my differential equation. I want to find a particular solution. What's the first step? Separate the x and y. So I'm going to move the dx to the other side. How do I move the 2y minus 6? We're going to divide it. So now I have this. All right, we got, what do we use for the left over here, guys? Integrate that. Say it, bring music to my ears. What were you saying, Lars? No, I'm not going to bring it to the top. Oh, you're talking about the one on the right? Yeah, you're right. That one's cool. All right, so you said x to the third over 3. This guy? No, it's not tangent. Nah, it's not, son. We've done it. It's an ln. That's true. And it's the shortcut I shared. You guys are having a hard time seeing that shortcut. All right, so remember this? A over bx plus c is a over b ln of bx plus c. So that's what we're going to go for there. So it's going to be what? 1/2 ln 2y minus 6. Now I just want you guys to know how this thing is graded, by the way, on these FRQs. This is 1 point, getting your variables separated. Each of these are 1 point, doing your integration on one side, so that's 3 points. All right, it's worth 5 usually altogether. What's the next thing we do after we integrate both sides? You enter your particular solution. So let's do that. I'm going to have to erase because I'm running out of space here. And I'm going to reduce this, by the way, just to make my life a little bit easier as well. I'm going to cross off those 3's. All right, what am I plugging in for y? 2. What am I plugging in for x? If you cube -1, it's still -1. The absolute value of -2 is just 2. Double negatives is positive. All right. Now what? Get c by itself. So what would we do to get c by itself? Sure, -1. Now, we don't usually get really ugly c's like this, but this is an ugly c. The good news is, even though it's really ugly, You really don't have to do anything with it. That's just your C. It's just really ugly. But that's okay. It's just sitting there.
You really can't get rid of the ln at all.
No, not on this one. Like we talked about how ln of E equals 1. We talked about ln of 1 is 0, but this is ln of 2, which is just a really weird decimal answer, so we're just going to leave it. All right, so there's my C. Can I erase?
Yeah.
No objection? Now that's another point. So now we're up to 4 points, finding your C value. 1/2 ln of 2y minus 6 equals negative x cubed. And was it plus 1/2 ln 2 minus 1, right? Okay, so there's my C, and that's another plus 1 there, finding your C value.
How did you get the negative x3?
I reduced the 3 over the 3. All right, now the last step. What's the last thing we want to do? Get the y by itself. So to get the y by itself, what's the first thing we would do? Multiply everything by 2, right? So we're going to do times 2, times 2, times 2, times 2. So for this first one, these go away, and I'm left with ln. This is going to be negative 2x cubed now. These just cancel each other out, so I just have ln. That's going to be minus 2. Now what do we do? Getting close, yeah. So we want to get rid of the ln, and we do that by exponentiation. We're going to exponentiate both sides, make both sides the power of e, right? So these cancel here, and now I have the absolute value of 2y minus 6 is equal to e to this big long power here.
Where's that still on?
This? That was 1 over 2, and since we multiplied it by 2, it canceled out.
I just got
All right. We ready for the next step? How do we get rid of the absolute value bars? Yep, we're going to write 2 equations. We're going to write 2 equations. So 2y minus 6 is going to be equal to plus or minus e to the negative 2x cubed plus ln 2 minus 2. And at that point, I think you guys know what we'll do. We're going to add 6 and divide by 2, right? So let's do that. So add 6. Divide by 2. So I've got y is equal to. Now, what do you guys think? Positive or negative answer? Yep, so we're going to go with the positive one. So I'll circle that. And here's my final answer. Maybe draw an arrow to this if you didn't know why we circled the positive one. Since our y value is positive, we would expect it to be positive.